Hi, welcome to Computing Foundations. This is a YouTube channel for beginners who want to learn about computers, programming, and the math, science, and art behind this world-changing field. I'm Josh Kilpatrick, a retired software engineer. I want to take a second to invite you to like, subscribe, and share your comments to help me improve this channel. This video is a review of the solution to our programming challenge number 14. If you're new to the channel, you probably need to take a second to read the instructions linked in this video about how to get set up to make use of my videos. In that introductory video, you'll get an introduction to my GitHub repository called Computing Foundations, where I have example programs that go along with each video in the channel. And occasionally in a given video, for example, my video number 14 with a lesson on C programming structures, I also have an example challenge program that's designed to give you a chance to practice your programming and try out some of the concepts I've been telling you about in the videos. So that's just a quick introduction to how my videos are organized and how you can make use of resources in my GitHub repository that will help you learn faster. Okay. So Programming Challenge 14 was a continuation of Programming Challenge 13, where we developed a very simple phone book, and the program allowed the user to add new entries to the phone book and to display the phone book. All we're changing in Programming Challenge 14 is we're making use of the new concept we learned, C structures. Instead of defining parallel arrays to represent our phone book, we are instead defining a structure of an array of structures. So let's jump right in and go over the solution to the program. First of all, let me jump you to the main program, the main function. You'll see that the main function is almost identical to the solution we did for Programming Challenge 13. Instead, though, of defining various arrays, I've defined an instance of my structure phone book. I'm initializing the size of the structure to be 0. And then I proceed with a do-while loop and a switch statement that will listen to the user's selection of commands. We support the add command, the display command, and a new command which is used to show memory for the program. Finally, we also support a quit command. And you'll notice I just call into a function that I've defined for each of these different actions that can occur. There are 3 functions: the add function here on line 194, the print phone book function on line 200, the print memory function on line 203. So I just call one of these functions based on what the user selected until the user says, I want to quit, by entering a Q. So this looks exactly the same as the program we wrote before. So what's different? Here at the top of the program, you'll notice I have defined an enumeration and 2 structures. Let's start with the structures. So first of all, I define an entry structure. Each entry in the phone book will have 4 variables: a character array called first name, a character array called last name, a character array called phone to hold the phone number, and a variable type of entry type. Entry type is an enumeration that I've defined. What is an entry type? Well, here on line 42, I defined my enumeration entry type to have 3 values: family, friend, or work. the idea is that a user can define each entry in the phone book as being either a family member, a friend, or a work contact. Then I define an array. I want to describe to you this technique. On line 43, I define a multidimensional array. It's an array of strings. And the purpose of this array is to provide a string representation of each value of my enumeration. This is a common technique when you want to be able to print the value of an enumeration to the screen and give it a meaningful human value. If you just print the enumeration variable as it is, it just prints out an integer to the screen. Each of these values of the enum type are 0, 1, and 2. But if I just print 0, 1, or 2 on the screen, the user's not going to know what that means. So it's common sometimes to create an enum and then have an array that it represents the various values of the enumeration in string format. So that's what I'm doing there. Finally, I define a structure called Phonebook, and a phonebook is made up of an array of entry structures. So here I define an array of my entry structure. And I also add a size because the phonebook needs to know how big is it? How big is this phonebook? All right. So then we come down and the print phonebook function works identically like it did in Program Challenge 13, except I'm passing in a pointer to my phonebook structure. This will give the print function access to see all the elements of my structure and print them out to the screen. If I want to be extra safe, I can define this pointer as a constant. That will make absolutely sure that it is impossible for this print phonebook function to change any values inside my phonebook. That would make sense because we don't want the print function to change anything. We just want it to read the structure and print to the screen. My add function, however, cannot use a constant pointer. It needs a pointer that it can change because we need to add entries into the phonebook. So you can review here how that functioned, how I received a new entry into the structure. It looks just like Program 13, but instead of operating on arrays, I'm operating on my structure. So you should be able to see how this functions in my example. Lastly, I define a function called print memory. The print memory function makes use of another function called print chars, and I'll show you both of these functions. The print memory function is going to simply ask the user, which phonebook entry do you want to see the memory for? And the user needs to pick a value 0 to the size of the phonebook to indicate what entry do you want to look at. The user will enter, this function will capture that into entry num, an integer, and then finally we'll call the print chars function. In the print chars function, I'm simply taking a pointer to a character, and then I'm walking through the memory, printing out one by one the bytes. I'm going to go ahead and change this to an unsigned character just to make it, well, no, I take that back. I'm going to leave it like it is just so you understand how I'm doing the casting here to an unsigned character. We always want to print memory characters as unsigned characters if we really just want to see the contents of the memory. So that's why I've defined that as an unsigned character. All right, let's run this program and see what we think. Having some hard time typing here. Okay, so here's our command to compile the program. Oops. I entered in the wrong command. GCC 14-challenge O out 14. Okay. All right, our program compiled without any errors, and now I'm going to run it. Okay, as we'd expect, I'll make this a little larger for you. Down here at the bottom of the screen, Phonebook. Add A to add, D to display, M to print memory. Let's add an entry. I'll enter A. First name, Josh. Last name, Kilpatrick. Phone number, 777-888-9999. Category, let's call that family. Okay, we finished our entry. Let's display the phone book. I'm going to enter D. Ah, look, there's the entry. Josh Kilpatrick, there's the number. I'm a family member. Looks cool. Let's add another one. Add. Let's add Peter Parker. He's available at 111-222-333, and this is definitely a work friend. Let's display the phone book. Okay, now we have 2 entries. Looks good. Let's try the new memory function. I'm going to enter an M. Okay, it asks me, what entry do you want to display? Let's display Peter Parker. That's entry number 2. So that's index 1 into the array. Okay, what I want to do is walk through with you now, what does a structure look like in memory? Well, let's take a look. We defined our structure in a certain order. So the structure has a first name, which is going to be 16 characters long, a last name, which is 21 characters long, a phone number, which is 17, and then finally an entry type. So 4 different variables that are going to get packed into the memory location of the structure. Now, let's take a look at what this actually looked like in practice. So we start with the memory address of the beginning of the structure. And we're going to look at each byte. And what do I see? In memory address position 0, I have P for Peter. And look, I can see here, P-E-T-E-R, Peter. Then I have a space and another space. Then I have, I'm sorry, let me correct myself. Then I have, after the last R in Peter, a null character, 00. That means the end of the string. And then I begin to have, starting here at position 6, a lot of nonsense. This doesn't really mean anything. This is just a bunch of meaningless characters that were left in memory. This makes up the other 16 elements of the array that I didn't use. Remember, the first name can be up to 16 characters long. I didn't use the 16 characters. So here they are, unused spaces in memory. Until finally, I arrive at the beginning of last name. And we can see here, we have Parker. And then after the last R, we have a 0 null character marking the end of the string. But there's still extra space left over for the last name that I didn't use. Here it all is in memory with a bunch of gobbledygook. Okay, we continue in this way until we get to the end. And then here at the 37th byte of the structure, we begin to see the phone number. Here we have 111-222-333, the bogus phone number that I entered for Peter Parker. And again, the null terminating character at position 46. So then we continue with meaningless data until finally, in the last 4 bytes of the structure, I'm going to have to sort of show you this example again because it's very hard to understand what we are looking at here. But This is where in the last 4 bytes, we're storing the type. This is the type of the entry. And we entered in, I believe that he was a work friend. So the work type has the value 2. 2, because we have 3 types. The first type gets the value 0. The second type gets a 1. The third type gets a value of 2. So if I said he was a work friend, that means a integer 2 should be stored in memory. And what do I see stored here in the 56th position? This is the least significant byte of a 4-byte integer. So we see the 2 right there. And really, because there's only 3 possible values, we're only ever going to see 0, 1, or 2 in this last 4 bytes of the structure. So in this way, you can see that the structure is simply a contiguous segment of memory where each of the variables that I've placed in the structure get packed into memory in order, and there we have our entry. So that's the end of challenge 14. I hope you were able to find the solution on your own. If you struggled, don't stress. The entire point of these exercises is just to exercise your mind and continue to expose yourself to the process of solving problems using computer programs. You're coming along amazingly. We just have a few more videos left in this introduction to the C programming language. I hope you enjoy them, and I hope to see you soon in the next video.